I changed the subject and changed it to the brain advanced numeric modeling back in house. And the reason I changed this one a bit because my background is mostly in operation, and I like to do everything in operation. I see the value in modeling, especially when you do a calibration. And I believe the calibration is supposed to do the operation, and people go on and see the underground. So you see that value when I can do the calibration, and you can see the value in the model. We're going to go through the challenges when you're doing modeling and the solution we thought about it, and the reason why we use the FLAC3D to develop this workflow, the economy and safety advantage of the method, how the difference between this and others, how to use it, and conclusion. So in terms of challenge, when you're doing modeling, in most cases, so there is, in operation, mostly there's a lack of, as you can appreciate, there's a lack of people, experienced people, especially in the model, with that expertise. In most cases, we have a lot of pressure coming from the operation to do operation on day-to-day jobs. So you don't have too much time to spend modeling, especially getting to that calibration and getting that backlash. The next one is there is a dynamic situation in mining. So something happened, everything changes, sequence change in 2 weeks or a couple of weeks, or the blocking changes, or everything changes. Mining coming and change everything. So whatever you have done, even you are pretty good at it, by 2 weeks, it's almost a waste of the time for you, most of the cases. I've done several for like a long term, mid term, after 2 weeks of reporting everything, because the change was almost no value in what I've done. The next one, if you go to the direction of consultant, you're a good consultant, you have to reduce cost, and then time, sometimes takes time to approve everything, and give it to them, and the company come back again, costly, and sometimes again back to that changes in the mining, there's not much value. So in a couple of years, we worked through it, and we thought using a technology and come with some sort of workflow that helps you to remove this process from people, will help you to bring that model back to operation. So that solution, that workflow is supposed to be very easy to use, it's time efficient, it can be easily adopted to the new situation. If you change it today, you can adopt it and run it again, and you get the result. And also, in terms of cost, it's very cost effective. When you run it, you just run by you guys, or something in the operation, so it's very cost effective. So, in order to develop that workflow, we went through the stress resistance solver that exists. We developed a code within the house, but it's not commercial. So we went through the commercial. So mostly we're using 4 software in mind. And Mapping and Austria, I believe, is the most useful or most user using those two. FLAC3D and Abacus is probably the least favorable among people. So we put some criteria and look at the options that we have to be able to use it for our benefit. So if you look at so we've been talking about the Monday mining and STOPE especially, you want to see which is more reliable method to use it for that. So if you're talking about explicit, implicit, you're looking for explicit method and solver that helps you and create a more reliable result. And also, you need to use a solver that is handle a large information. And next, and very useful and very important item is it should be fully flexible. To be able to change it as you wish. And so it should be a very code-based sort of solver thing. So we end up using FLAC3D as a solver for our cases to be able to do what we're supposed to do. So if you look at basically modeling, the steps of modeling in general. So you prepare your geometry, and then we go and go to the next one, which is more time consuming, obviously everybody knows, is creating mesh. K-mesh is the most probably annoying part of the model. And next you assign your control parameter and then run it. In a running part, the most things that most people in operation not doing it is the calibration. That's the most important thing and time consuming because you have to change the parameter, come back and redo it. And by the time you're doing it, you want the best case, most cases I've seen, they create the mesh and after the result, they don't go through that process. Anyway, and then you go up all the plots and create the plots based on best resistance range most of the cases. Look at them, I interpret it, and then you report and make a decision. That's basically the steps that we take. In the next one, out there is a couple of tools, useful tools that helps people to assist steps generating that mesh for you and assign those parameters. So that's very helpful. That's helpful for you to assist that part. Still, you involve third party, so you have to go turn on the software, run that one, go back, solve it, and get the plots, and etc. What we thought, and what we wanted to get to the point that you get when you prepare your shape, etc., you'll be able to run it and create for you, and the only thing you need to do is reporting and decision making. We wanted to make it very easy for people to not be involved in the middle of it, because that's the part you need to save the time for it, so you'll be able to do the other stuff which is important for your operation. So be able to go run it, go to your stuff, come back, have a look at it, so if you don't like it, change it, rerun it again, until you're satisfied with the result. So and be able to create a plot for you automatically with high resolution. Just look at the plot, make a decision, go back, come back, again and again. If you want to change the situation, I don't know. Well, we want to change the pillar size, again, run a couple of scenarios without any issue into it. So that was what we developed through this workflow. In the general, we look at how you do the modeling. There's two options for operation. Either you do it in-house by people you have, or you give it to consultant. We have the third option, which is using through this automation method. And if you look at most cases, when you do the operation, most people, there's a lack of expertise. However, if you're going with the consultant, again, it's going to be cost and time probably involved. But with this automation, when you look at it, it's going to be time efficient, it's going to be very customizable, it's going to be repeatable, it's going to be consistent in terms of what you result in, and regardless of how complex of your situation is, it's going to run it for you without too much of involvement in mentioning, etc. So it becomes very easy and smart tools for you to make a decision. If something happened and you have three options, you want to run it today and come back and get the result and make a decision. That's very useful and powerful tools for you. How you use this one? So, in order to this one, cool. So when you open up the flag, you're not involved with the flag. Because I know most people, this is a code-based software, they're not interested to use it. You're not interested to show you how to use a flag. What you use that software to run this one. When you run it, there's a button that you click. The interface that we created is pop up for you. That's all you need to know and play with it. It's got 4 sections in it. Okay, stop this one for a second. It's got 4 sections. Anyway, we've got 4 sections, top of the section. Model configuration, and then all the geometry is going to input as input, and the parameter is going to be which we wrote about this one. focus on that section. Yeah. Anyway, I'll keep going. That's what's all right. Oh, good. We've got 4 sections. The third section is about the input that is going to be all the roughness strength. And then last section is if you want to save any stage that you reached. So in the first step, in the first section, you can have a new mesh. If you have a different mesh, or you can use just change the parameter. There's a concept model is customable. You can change as you wish, but here I'll just put 3 for a hard rock, which is the most useful one, put brown, high mass, and round there for a sort of a time situation. The next one is a boundary model, boundary size, which is predefined, or you can manually put your model size. The next one is the rough mass strength. We're going to talk to it later. If you want to save your after each step, you want to save your file, you can tick that one. If you want to create a plot after each sequence, you can tick that one. In the next one, you choose all this geometry in a different category. You have future mining, all the shapes coming from future. You have a CMS, all the CMS coming from next one, development, and also all the lithology. You have a lithology and also all the faults coming through it. So you collect all the information through that one. In the next spot, you have file input. In a file input, basically all the rough mass information that you have in the system, you put it through that one. In-situ stress, obviously, you put the in-situ stress here, and if you want a different plot, you can add what sort of plot you want to look at the stress, look at the different parameters you can put add it here, and it automatically generate those plots for you. And as I said, next one, the last one is if you want to save, because most people interested to save next 3 months to look at and play with the different section. So when you choose those one, all you need to do next one. So there is a small as well hidden sort of parameter that we put in the background for advanced user is that how many sizes you want to write, or the size of the zone. Also, if you want to change the color, just adding some feature in it. So when you're happy with this input, all you need to do is run this one and copy it. When you stop it, and you're going to go in the background and check a couple of things for you and make sure everything is sorted, and if there's error, come back to you and tell you. When you run it, it comes with this one, so you confirm all the information that you put here. If you're happy, confirm and run. If you're not happy, cancel, go back, change it, and then run it again and confirm. So by confirming and running this one, that's all you need to do. And you're going to automatically run it, and it spit out all the plots and result for you. And you can go back to the folder, open it up, and have it again, or look at the plots. So we time this one under 3.5 minutes, you run the model very softly without involving anything of any sort of very difficult understanding the background. And also we add a lot of comment here. So which stage is importing the files and how much percentage of your model is completed. So you can see which stage of the modeling you are in. Depending on the size of the model, it takes a day, a couple of days. I run the micro for this one. It took me 3 days to do the whole mine model. And if you mine like US dollar node running model, probably it's going to be 15 minutes, 20 minutes. I'm going to run it for you. Come back to you. Basically, that's a very complex situation become a very simple sort of run and through this automation. So as I said, it's going to automatically generate those outputs, but the output we create is a bit different. We're not interested to look at the stress strain because you need to understand it to become something that is useful for you. So we change to the risk-based sort of outputs, and automatically generate this one and save values. You can see all this one based on the name, days, and sequence is saved. Then we can put it together and create a clip of the changes to the steps. I said this is the risk base. So we, for example, the squeeze in this mine, we look at the squeezing potential. So we change those outputs to become a risk base, and you can simply, easily, people, regardless of your background is mining, whatever it is, you can easily pick up the issue. Where's the issue, and how can you deal with it? You can run it through this one and look at it and come back to that. Same thing if you look at the spalling or seismicity, which is in this mine, there's not much because you have a squeezing, there's not much spalling happening here. Probably just to give you a size, I think it's 300, 400 stopes in this model. That's the workflow. Beside that workflow, we developed a couple of small tools, which is useful in our belief for people dealing with this model. One of the questions always asked people is how you calibrate your model, how you reduce or increase your parameter. Because if you increase one of them, it doesn't make any sense. What's the scientific way of doing it? So, and to answer that question, we can again bring this one to people to do it by themselves. We developed a small tool that it just, in terms of statistical sort of method, it reduces all the parameters for you or increase it. So we call it from P30 to P70. So P50 is what you have in an average model database. And to reduce this study from using a Carlos method with 1,000 seeds, you reduce and increase it, and it gives you a basically graph, and that curve give you a P30, which is weakening your parameter all the way through, and go to P70, which is make it stronger. So you can run different scenarios based on those ones. So that's create those numbers for you. The next tool that we kind of developed for it again is a shape checker as an evolution. So a lot of issue we have is when you create a mesh and export it, it is not validated, there is an issue with it. So when you run it through it, it's going to tell you whether it is closed form. If it's not closed, it's going to close it. If it can, it's going to tell you exactly where's the point. And you can just fix it in your mind software. Fix it and attach it. The other useful aspect of this one, when you have a boundary of the model, it's going to tell you exactly your boundary model is going to be. Because the top is going to read everything and give you expanded and create that boundary for you. The next one is, I think it's we developed for people to kind of educational or explaining things for people and how the matter responds in a model. Because as you know, when you're doing elastic post-peak and plastic post-peak, not separation, and you have a separation side of it, which is, it goes to plastic. So there's a separation between the separation part, which is failed material, but it's not failed. So your overbreak is happening where you have a failed material, but it's separation happening. If you consider that, look at the result and it's failed, but not separation, it's not considered as an overbreak. So that's really useful for when you're doing a stope optimization and you look at the stope performance, and it helps you a lot to look at this information. In conclusion, the plugin or the workflow that's developed is nonlinear sort of advanced sort of modeling tools become very useful and easy tools to implement in your day-to-day task for you. It's not just the software, it's easy tools for you to make a decision because you can run different scenarios and the output that come out as respect. So you can easily make a decision. And also, regardless of your size, you can full scope of the whole mine, or you can use single stuff going to run it for you. It doesn't matter what size for it. You can run it. So I usually run this one in operation in the morning, run this one, go on the ground, do whatever it's supposed to do, come back and look at it. If I don't like it, run it again, again. So that's become very easy for me. Output is a risk base, not a stress strain. Most people struggle to understand or not easy, at least when you can run multi scenarios. Again, you have a stope, you want to look at the pillar size, 5 meters, 6 meters. As somebody asks you what's the optimized, you can give me all the shape for 6, 5, 6, 9. And give you a design. And the bottom line is the fastest, most cost-effective tools for you for identifying the hazard and mining. So we put all these together in a package, and we call it ts.STOPE, and we made it commercial recently, which is available for people if you want to use it. Thanks for your attention. And if any questions.